So let's talk about BSP. BSP is the way that the memory is going to be allocated within your scene. How Mentor is going to be allowed to use the available memory to process the scene that you've got. And you've got a couple of different options in here. One of them is BSP, which stands for Binary Space Partition. One of them is Grid, and one of them is Large BSP. Large BSP will basically create multiple BSPs, and the reason for that is that, theoretically speaking, you would be able to render any size of scene with using large BSP. It can average, it can give you a performance hit of 15 to 20%, but at least you'll be able to render the scenes where sometimes your memory requirements will be too extreme and it just simply won't be able to render it. For example, if you have a really complicated displacement or you have very dense pieces of mesh, it can create problems for the BSP, and the only way you're going to be able to get it to render is to use a large BSP. So the other option in here, of course, is grid. And grid is sort of an older way of calculating memory usage within the scene. And basically what it does is create a unified memory structure over the entire scene. So in some parts of this grid, for example, if we had a very dense piece of geometry back here and another one over here, but nothing in the middle, it would be forced to up the grid resolution to take into account what it needed for this guy and for this guy. But unfortunately, everything else in the middle would also be required to use that kind of density. And it just turns out to be a very inefficient way of calculating RAM usage. So that's where BSP comes in, and the BSP is going to be creating memory structures for individual objects within the scene. So if it needs to create a very dense memory structure, for example, for the scorpion, then it'll do that, and not so much for the plane, because it's a simpler piece of geometry. You have two different options in here, BSP size and BSP depth. BSP size is the number of shaded vertices that are going to be taken into account when you function the render, and the depth is how deep it can extrapolate them. So you can sort of think of this as a tree, and this is the size of the branch, and this is how many levels the branch has. The higher this number, the more pieces of information it takes at once, and the less amount of memory that it uses. So if you've got a problem where you're running out of RAM, using bigger and bigger BSP size numbers can help by decreasing the amount of RAM that it's going to need. So on the flip side of that, BSP depth, the bigger these numbers are, the faster the scene is going to render, because the deeper it can draw the tree. But on the flip side, the more memory it can use. And also, having a very deep BSP, or having very high numbers in BSP depth can also dramatically decrease the performance of your motion blur. And that's something we'll talk about when we get into motion blur here in a minute. But when you have motion blur problems, sometimes getting that number further up there, so closer to 0, can help dramatically with the speed of your motion blur, but then it makes it more complicated for it to extrapolate really deep values that might be needed if you were rendering a very complex piece of geometry, for example. So theoretically speaking, the highest number that's going to be of use in the BSP depth is 55, so going much beyond that's probably not going to make a lot of difference to your scene. So let's take a look at a diagnostic which will help us pick apart what the BSP is doing, and we'll see how it's building out its memory structure. So underneath diagnostics, you've got a couple of different things, diagnose samples, and then this is going to allow us to pick apart the anti-aliasing stuff, which we'll get to in just a minute. And then we have diagnose grid, how it's going to draw the diagnose grid, and then diagnose BSP. The thing that I'm most concerned with right now is diagnose BSP. I can have it represent depth and I can have it represent size. And the more that the colors change on this image that we're going to generate, the more that it's changing through each one of these settings. So right now I have this set to 15 and 35, and we can just go on ahead and do a render. And you'll see that the geometry here is not terribly dense. This is just a poly model. It's a poly model that I created out of a NURBS patch model that I had. So I'm going to use a hotkey and pull up my render view. And again, I tend to use a lot of hotkeys. All this stuff is accessible through, for example, Window, Render Editors, Render View. I'm going to use my hotkey from here on out. And there's my scene. If I want to, I'm going to say render snapshot, and I can say current, and it'll give me a snapshot of what my current scene is. And I can just go on ahead and tell it to render out the scene. So initially I'm going to turn off the BSP size. I'm going to turn this to off, and I'm going to render it out. It'll just generate this image. Now there's a couple of things here that I want to look at. One of them is the render options box, or the output box, just popped up as soon as I kicked off the rendering. You saw it stream through a whole ton of different information. And if we go backwards and look at the information that's being stored into here, basically you can see that what's happening when you kick off a render within Maya is that it's having to translate it into mental ray and then create the render. So there always is going to be a mental ray translation, which will show up down here, and I'll point that out next time we render. This is, again, a light scene, so there's not a whole lot of time to look at this stuff. And then you can see the information that's being output and how it's going through. So, for example, the option of face is turned on and it's rendering both. The fields is not outputting to fields. It does have the ability to render hair turned on. Again, just all these different things. Now, it's outputting the render stats as it goes through. This is the progress message I was talking about that is going to allow us to diagnose the render if we have any issues. And really all it's doing is showing us progress. There's not a whole lot for us to pick apart in this. And then towards the end of the scene, this is interesting, it gives us the output statistics. So it tells us, for example, what the maximum depth that it was using, what the maximum leaf size that it was using. I'm sorry, what the average, these are the maximums and these are the averages, which is a way that you can actually adjust your render globals, which we'll talk about here in just a second. And then also how long it took for it to compute the render, which is basically 2 seconds, 1.99 seconds. So that's what this guy is doing, and it's going to help you pick apart the render as you go through. I'm just going to close this thing up, and I'm going to go back into my render globals, and I'm going to turn on diagnose BSP, because we're not using a grid, so I don't need to worry about that. I'm using BSP. I'm going to tell it, for example, to diagnose depth. And as I render this through, it'll generate this color image. And it basically shows you each time that it subdivides to a different level within the depth. The more that the colors change, the further it subdivides. So you can see it gets deeper and deeper on fine levels of detail, and then it stays fairly shallow on big, undense areas. And if I go through here and swap these numbers around, for example, maybe I pump that up to 55 just to see what it'll do. It doesn't generate as many different levels. If I put this down to 15, you can see that it goes very deep on certain areas and not so much on other areas. I'm going to put this back to 35, and I'll kick another render for us, and I want to point something out real quick. Inside of my output window, we'll have something that says average leaf size, average leaf depth. Average leaf size is set to 10, and the average leaf depth is set to 24. Theoretically, if you use these numbers outside in here, inside of your initial BSP settings, they sort of provide an optimized version of what these numbers are. So it's saying that for the average leaf size, all it was really using was 10. So I could maybe output or input 10. And for the BSP depth, it's saying that it'll only really use 24. So maybe I'll put 24 in the BSP depth as well. And if we take note of what the scene render time was, this is 1.63 seconds. And I'll render this again. Now it rendered out in 1.61 seconds, so it's 3/100ths or 2/100ths of a second faster. Again, on a more complex scene, some of these number discrepancies will be much greater, and you can see the benefit of adjusting this BSP stuff. Most of the time, you can use those averages to tune these BSP depths up. You just have to be aware of the fact that when objects in front of the camera change, then your RAM requirements are going to change as well. So setting these to the optimized settings for a single frame may not necessarily benefit you throughout the entire length of the scene. And the only way to really do this is to jump around through the scene and try some different settings and see what your render times are by adjusting these things down and try and get that to an optimized level. It is okay to render the scene partway out and then come back in here and adjust these numbers and render the rest of the scene out. For example, maybe we have a scene that's got really no motion blur in the beginning of it, like the camera's not moving very fast, and then towards the end of the scene we have some extreme motion blur. And the scene keeps on, and if my initial settings are set to 15 and 35, for example, the scene will appear to render just fine for the first portion of the animation, and then when the camera takes off and the motion blur gets real extreme, it keeps dumping out and it won't complete a render. If I was to come back into the BSP depth and set this number to 25 or to 20, for example, it's very possible that that render will now finish. And it's also possible that it's going to take a lot longer because we're not allowing it to draw the tree as deep. Therefore, it's not using up, or it's not able to speed that process along. So we're forcing it to make a shallower tree, which will allow it to use the more optimized memory structure, but on the flip side, it's going to take a lot longer to render. So sometimes you just have to do that in order to get the frame to kick out, but changing these numbers shouldn't have any effect on the resulting image. Let's take a look at another scene here. This is a bit more complicated, but it's still fairly simple. This now is a just this robot, and he's all NURBS. Okay, so there's a couple of things that are going to happen. Now, Mentoray as a renderer is not a NURBS renderer, it's a poly renderer. So it's going to translate everything in your scene over into polygons, whether it's subdivision surfaces, whether it's NURBS, it's all going to go into polys. So the way that it translates that scene into polys is what you're going to be controlling, for example, with tessellation settings, and it's also going to have a dramatic effect on the memory requirements for the scene, because the more polys you have, the more the memory is going to be required. So I'm going to go to my presets, say load presets, and go to initial settings, and this will get me to my initial starting place. So I know that I'm not going to tank out because of some tweaked out render setting, and then I'm going to go down to memory and performance. My BSP is set to R15 and 35, which looks good, and then I'm going to go into my diagnostics, and this time maybe I'll say BSP size, and I can render this out and see what happens. And again, all this is really helping us do is figure out where we might have memory problems within the scene, or just how the memory is being structured within the scene. And sometimes you'll have a scene that keeps on tanking out no matter what you do. Now, we have this set to BSP size, and you can see that everything is generally being taken into account in the same way, because we don't see a lot of discrepancy in the colors. If I set this to BSP depth and I render this back out, we can see this. One of the other reasons that you might want to use this to help troubleshoot your scene is maybe you have a situation where the scene keeps on tanking out and you've gone through it and you can't seem to identify any surfaces that would cause a problem, and then you do a rendering with diagnosed BSP, and for example you get an area of your render that's a dark red. That would indicate that there is an extreme amount of RAM or an inordinate amount of RAM that's being used in that one scene, or in that one object or one region of your render, and that could be the source of your problem. So then you zoom in and you realize you have a sphere set there with like 1,000,000 tessellation or something, and that could be the reason that the render is crashing. So it helps you go through and pick apart the scene and figure out where your problems are going to be. Later on, as we get into other areas of Mentoray, for example, photon mapping or final gather, we can use this to help visualize the way that the samples are being dispersed throughout the scene as well, as you can see in diagnosed photon or photon density.